Hello class and welcome to 3.4 composition of functions. In this portion of the video, we're going to go over how to evaluate composition functions using multiple representations. We're going to first look at how do we do this using just two graphs. So given a composition function and a graph, its individual functions evaluated using the information provided by the graph. So what you're going to do is first locate the given input of the inner function along the x-axis, read off the corresponding y value, the output value of that inner function from the y-axis. Okay, you're then going to locate the inner function's output value on the x-axis of the outer function of the other graph, and then read that output value, that y value, from the y-axis on the graph. This is going to be the result of the output of the composition of the function itself. I know it seems a little confusing, a little jargony, but when you look into practice and we see it into practice, it's actually quite simple. So here I have an example 5. All right, we have two functions f and g. All right, so pay very close attention to these. We have function f right here on the left and function g right here on, the other way around. G on the left and f on the right, okay? And we want to evaluate this composition here. We want to figure out what this is. So step number 1 is to start with the inside, g of 1, and figure out what does g of 1 equal, okay? So looking at function g, which is the one on the left side, all right, that's why I put it first, because we're going to start with the inside, so we start with this one first. We're going to look at the x value of 1, so along the x-axis, we're going to find 1, and then we're going to find the corresponding output value at 1, which is 3. So g of 1 equals to this value of 3, okay? So we know that the output value is 3. So what we're going to do now is that we're going to now use this answer 3, and we're going to plug it into the outer function, which is f, and we're going to use this as the input value. Okay, so we're going to do this notation now. So now what we're going to do is now look at function f, right, which is this one right here. Look at the x value, find 3, which is right there, and find the corresponding y value. The corresponding y value is 6. And that here is the answer of the composition. The fog of 1 equals to a total of 6. And there you have it. There is your response. Okay, now that we've done that example, let's look at this diagram to kind of correlate again what we did. So what we've done is that we plugged in a value again into this function g, and in terms of the graph, we just simply looked at the graph and figured out what the output value was. What we did then is got that output value and made it the input value to this other function, where the notation again is the f on the outside. So making this output the input value of this function f, we're going to look at what the y value is of f, and that output is going to be the result of, again, the composition. So we're essentially just doing, again, what this diagram is illustrating in a very concrete and not abstract way. So let's look at another example. Okay, so using the exact same function, we're now going to look at let's say this. Let's evaluate f of g of 0. Okay, so let me just shrink this. Let me just make this smaller so it doesn't go away. And we're going to do another parts to this. Okay, we'll call this part b. So let's evaluate, again, the same order, f of g of the number 2. Okay, of the number 2. So to figure out what this equals, excuse me, we're going to start again with the inside parts, which is g of 2. So step 1 is to first figure out what g of 2 is. So again, make sure that you pay attention to the notations of your function. So we're going to start with g of 2, right? And at g of 2, the y value here is equal to 0 because that's where the point is. At x equals to 2 right there, the graph goes through that position, and that point has a y value of 0, so 0. Now our second step is now to evaluate the outside function f using that output value. So we're going to get f and figure out what the output value is when we input this number of 0 in. So we're going to move to the function on the right and look at where x is equal to 0, which is right here, and the y value is down there at -3. Okay, and this right here is your response. That second number that you get from this composition is going to give you the Goff value when x is the number 2. You get an output value of -3. So now let's go over how do we do this. How do we evaluate a composition if we're given a table of the function, selected values of the function using a table instead of a graph? Well, when working with a function given a table, you're going to read the input and output values from the table entries and always work from the inside to the outside of the composition. We evaluate the inside function first and then use that output value for the inside function as the input of the outside. Okay, so again, very jargony, but again, it's very simple when we put it into practice. Now, because these tables again are fused together, one thing I like to do just to stay a little bit more organized and make it easier for me to read the numbers is to create a separate table for the two functions that I have. So f and g. Now the input values, the x values for each one of them is going to be the same. They're going to be 1, 2, 3, and 4. So 1, 2, 1, 2, 3, and 4. 1, 2, 3, and of course 4. Okay. Now to look at the corresponding y values, we look at the rows. So at 1, the y value of f is 6. At 2, it's 8. 3 is 3, and at 4 is 1. So the corresponding y values for 1, 2, 3, and 4 are 6, 8, 3, and 1, like I just said. So we're going to write those numbers here: 6, 8, 3, and 1. And then the corresponding y values for the function g when x is 1, 2, 3, and 4, looking at its row, are 1, 3, 2, and 7. So 5, 2, and 7. Okay, so there. Now that I have those values separated, I'm now going to evaluate this again, looking at the corresponding values. So again, we start always with the composition. So let's look at example 6a, and we're going to start evaluating again from the inside. Okay, so on the inside we have function g, so we're going to start on table g, which is this one over here on the right, and we're going to look at what the output value is when x is equal to 3. So our first step is to do g of 3. So g of 3, that it gives us a value of 2. So we're going to say that equals to 2. And now our second step is to evaluate f at that input value. So we're going to plug f into, 2 into f. We're not going to plug f into 2. We're going to plug the number 2 into the function f. And we can get that value because the work is already done to us by looking at the table. So when x is equal to 2, the y value is 8. So our answer is 8, and there is our answer. So f of g of 3 equals to the number 8. Now, the second example, same strategy, but now we're going in the opposite order. We're not going to start with g. We're going to start with the inside function, f of 3. So that's step number 1. So we have to look at the right table, f over here. Look at where the x value is 3. The output value is also 3. And now second step is now to work with the outside function g and use this as the input. So we're now going to plug in 3 inside there. So going to function g over here, we're going to look at where x is equal to 3, and the answer is 2. So there is your results. g of f of 3 equals 2. And again, we just continue with that strategy. So for the next one, we're going to evaluate the next one, starting again with g first. So g of 1, that's this one over here. When x is equal to 1, y is equal to 1. And then on this table, when x is equal to 1, the y value is equal to 6. So f of 1 equals 6. Now this one looks a little confusing because it looks like I'm using the same value 1 and 1, but I'm not. I'm using the number 1 because that's the number I got out of it, okay? So I'm technically using this number 1 and not that number 1. So there is a quite significance in which number I'm using, okay? Even though the numbers are the same. And finally, the last one. So we want to start with f of 4 first. So let's look at the table on f, go down to 4, and we see that the y value is 1. So now since that answer is 1, we're going to now look at g and see what the output value when x is equal to 1. So at g, we just did this one, when x is equal to 1, the y value is also 1. So this equals 1 as well. And there is your answer. G of f of 4 equals 1. Okay, and there you have your composition. And finally, the last one I want to go over is how do we evaluate a composition using the formula itself. So just like the diagram, as we did at the beginning of this video, we're given a formula for composing functions. We're going to do exactly like the diagram indicated. We're going to plug in a number into the inner function, see what number we get out, and then we just simply plug that answer into the outer function. So if I'm given my two functions, f of t equals t squared minus 1, and h of x equals 3x plus 2, and I want to evaluate this composition, I'm going to start with the inside part first. So I'm going to first figure out what h of 1 equals. So h of 1 would be 3 times 1 plus 2, which is a total of 5. So what I'm going to do now is that I'm going to plug this number in, this answer of 5, into the outside function. So I'm going to evaluate f of 5. So I'm going to plug this into the input values here, which in this situation I have two input values. I have t squared minus t, so I'm going to plug in the value 5 into both these t's. So f of 5 will be 5 to the second power minus 5, which is 25 minus 5, which is a total of 20. And I probably should have done that from left to right and put this over here. So let me just rearrange this and do that, okay? So we start here at 1. We get this answer, and now using the other equation, we now plug in this answer into our second equation. And the same thing would be true if we were doing this in the opposite order. So if I want to evaluate h of f of 2, I would start with the f function because that's the inside function inside this, which is t squared minus t, and start by plugging in number 2. So 2 to the second power minus 2 is 4 minus 2, which is 2. I then get this answer and evaluate it with the outside function. And since the outside function is 3x plus 2, this would be 3 times 2 plus 2, which is a total of 8. So there's your answer. H of f of 2 equals 8. And let's just do a couple more examples just so you could see again in practice. So again, h is in the inside, so we'll start with h first. and we're gonna now evaluate negative 2, so this would be 3 times negative 2 plus 2, which is negative 6 plus 2, which is negative 4. So here, we're now going to get this answer and plug it into the second equation, the outside equation, which is f. So f of negative 4 would be negative 4 to the second power minus negative 4. This is 16, and subtracting a negative is the same thing as adding a positive. So we end up with positive 20. So our answer is positive 20. Let me move this a little bit over. The same thing with this. Let me just move this a little bit over so I can write my answer over here on the bottom right hand corner. So f of h of negative 2 equals 20. And one more time, h of positive 2. So h of x equals 3x plus 2. And I think we already evaluated h of 2 somewhere up here. Where do I have it? I think h of 2. Oh, no, I didn't. Oh, yeah, right here. H of 2. H of 2 is equal to 8. So I know h of 2 is going to equal to 8. So I don't have to do that work again. I just now need to get this value and plug it into f of t, which again is t squared minus t. So f of 8 would be 8 squared minus 8, which is 64 minus 8, which is a total of 52. Yes, 52. So f of h of 2 equals 52. And there. This is how you evaluate when you're given the equation. Okay. Well, that concludes our notes for this second portion of 3.4. I hope this was helpful. If you have any questions, again, you can always email me or send me a message in Parent Square. And like always, I appreciate you watching. Now have a good day and goodbye.